Okay, for the last properties of solution, and this is part 2 of the properties of solution videos, we're going to talk about conductivity. The definition of conductivity is the ability of a substance to conduct electricity. Ability of a substance. Whoops, boy, that's downhill. Let's see, let me straighten this up a little bit. Sorry about this. To conduct electricity. So I always start this off by getting out 2 beakers, and I'll just draw my beakers here. And I put a conductivity bulb above it. My light bulbs. And into one of these beakers, let's see, let me make my water blue here. I fill it with water. And in one of the beakers, I will put salt, NaCl, and in the other one, I'll put sugar. And when I take this conductivity bulb and it's plugged into the wall, so there's current that runs into it, and then there's a prong, but there's no way for the bulb to light up because the current isn't complete. So the only way that this can light up is if when you put it into a solution, the solution can conduct electricity. So I'll put it first into the sugar water and nothing happens. And then I'll put it into the sodium chloride solution, and lo and behold, the bulb will light up nice and bright. So why is it that this is able to carry a current and this is not? Let's get some terms out of the way first. If a solution can carry a current, it's called an electrolyte or an electrolytic solution. So this can carry a current. If it can't, we call it a non-electrolyte. A non-electrolyte. So sugar water is non-electrolytic, but sodium chloride is electrolytic. So we talked about back in the first or second video, I think it was the second video, we talked about dissociation. And we said that when we put sodium chloride in water, so let's come down here. So if I put solid NaCl solid and I dissolve that in water, what I get is sodium ions and chloride ions. So before I can explain why this is significant, I should back up a bit and talk about what is electricity. The easiest way to think of electricity is moving charges. Charges that are moving. And the most common form of electricity that we're used to is the kind that you get out of the wall. When you plug something in, the charge that is moving are electrons. So what we have running through our copper wire are electrons. So let's do some examples here. We have moving, could be electrons, and those have a -1 charge. In your body, when you conduct a nerve impulse, you get a flow of sodium ions. So your nerve cells, we have a flow of sodium, and that's got a +1 charge. It doesn't have to just be electrons. It could also be sodium in your muscle tissue. Here's another example. In your muscle tissue, you get a flow of calcium, and that has a +2 charge. So it doesn't matter what the charge is. If it can flow, then it can conduct electricity, or it's considered electricity. So what do we have going on down here? If I had a beaker full of sodium chloride and it was solid, and I put my conductivity bulb in, this would not conduct. Now it's not called non-electrolyte because it's a solid. This electrolytes and non-electrolytes refer to solutions. So these are in solutions only. Solutions. this sodium chloride would not conduct, but when it dissolves into its ionic, the cation and the anion, it will. And this is why. I'm going to send electrons down from one side, and those can attract the positive cations and push the negative anions to my other probe. And because these charges are loose, so these loose charges allow for conduction. So why doesn't sugar conduct? We know it has to be a little bit polar because we said in the last video, like dissolves like. So in order for it to dissolve in water, it has to be a little bit polar. And the answer is there's not enough of a net charge on sugar to allow it to carry this electricity. It's just not there. What about water? Can water, one of the other things I do is I will put the conductivity bulb down into just a plain old beaker. Whoops, color's the same here. I don't like changing colors. So what if I have just plain water? Turns out if I put just plain water into a beaker and I put my conductivity bulb over top, it does not light up when I insert it into the water. And you might be saying, wait a minute. I see on movies all the time, people like on murder mysteries, they drop a toaster into somebody's bathtub and it kills them. Well, it turns out water is not an electrolyte and it's not actually a great conductor of electricity. But when you take a bath, you are not neutral. What is all over your skin? Especially like, let's say you went out and you were playing basketball and you're taking a bath because you're all sweaty. Well, have you ever tasted sweat? What does sweat taste like? It tastes like salt. And it turns out that the reason that bathtubs are so dangerous isn't because water is necessarily such a great conductor of electricity, but because we throw a whole lot of this stuff in of our bodies when we take a bath. That's the same way with like salt water in the ocean. The water itself isn't the conductor, it's the anions and the cations. But so really almost all, what's one of our takeaways here? All ionic compounds are electrolytes. I'm sure there's a few exceptions, but almost all, because they break into cations and anions. Because they break into cations and anions. So the takeaway is, let's do our takeaways here. The conductivity, the ability of a substance to conduct electricity. And we call solutions that can conduct electrolytes and solutions that can't non-electrolytes. And what we see is often the solid form can't conduct, but when we break it into these loose charges and we put it in water, now it does become capable of carrying it. And so we see this for almost all ionic compounds. Now, some of the things that can dissolve in water, like sugar, even though they can dissolve, they are not necessarily electrolytes. And we use this property to kind of group solutions, like you're either an electrolyte or you're a non-electrolyte, and it's a descriptive, a way to describe one solution to another. Okay, that takes care of our properties of solution. In the next 2 videos, we're going to talk about how do we express the concentration of a solution. Is it a weak concentration? Is it a high concentration? And how do we tell? But that's it for now. Thanks for watching.